question 10, right? Let's see. As with all questions, right, we need to, the description is very, very important. Like the way you look at your description is very important. You don't wanna, you know, what you may call, you don't wanna underestimate your description. So it says here in the diagram, right? And our description, yeah, whatever we do, as said many times already, we read it, we look at the sketch. You read it, you look at the sketch. So it says here in the diagram, the circle with center F. Let's see here, we have a diagram and we have a circle, right? And in the center here, we have F. So there you go. They said here in the diagram with center F, F is drawn. Wait a minute, what? In the diagram, the center with center F is drawn. Okay. Then they said points A, B, C, and D. Okay, what are those points and where are they? There is A, okay, B, C, and D. So already just by drawing these points, a lot of things are already coming in mind. For example, B is an angle that is subtended by AD. C is also an angle that's subtended by AD. So automatically, these are equal to each other. We don't have to read the whole description for us to start spotting things that are equal, you see. So furthermore, as long as we can see that there is C here being subtended by DE, another thing that is easy to spot is that F1 is subtended by AD as well. So automatically we know that this one is double C, and it is also double angle B. Does that make sense? Yeah, because of our theorems. You see, this is where Dr. Cape Town comes in: diameters, radiuses, cyclic quads, parallel lines, and tangents. So what we're dealing with here is like the radius lengths. This is a radius, this is a radius. So we need to be conscious of where they are going, so that we are conscious of what is half, what is equal, all that. So let's see what else here. They say they lie on the circle. Fine. One statement, or rather two sentences in, and we have like two theorems that we have identified. Next here it says chords AC and BD. Where is AC? AC and BD intersect at E. Okay, fine. There's a point of intersection here, which is cutting this into four sides. 1, 2, 3, 4. And then it says here they intersect at E such that EC, where is EC? EC is equal to ED. Okay, so that's gonna make this equal to that. We might as well add that. As long as it's not too cluttered, let's just add it. You know, these are gonna be equal because they are base angles of an isosceles triangle. Next, they said K is the midpoint of chord BD. So this is important. K is the midpoint of chord BD. The reason why this is important is they're trying to tell us that FK cuts BD in half. So automatically they're giving us another theorem. They're trying to tell us that this line is equal to the other side, right? However, what is actually more explicit is the fact that this is a 90-degree angle. That's like theorem 1. A line from the center of a circle, if it bisects a chord in half, then it means that it bisects it at an angle of 90 degrees. So that's important for us to know. The fact that BK is equal to KD. This is information that is given. However, it then just means that FK is perpendicular to BD or DB, whichever way you want to write it. All this information is stuff they're literally like telling us from the description. The one thing that maybe sometimes makes Euclidean geometry difficult or look difficult is that when you're reading a description, sometimes it's difficult to see that way they're actually just giving us everything. But they don't just give you everything in plain sight. They just try and hide it in whatever they're saying. But then the more open you are to knowing that, okay, I have different theorems and these different theorems, they work in different ways, the easier it's going to be to spot these things. And unfortunately, it's all a matter of repetition, you see. With all that being said, they're now just mentioning just random things, right? They're now saying that from that being said, right, FK, which is this line here, AB, which is this line there, CD, which is this line there, AF, which is this line there, EF, which is this line over there, they are all just drawn in our sketch, right, after having to have mentioned the important things. So you can see how they have literally distinguished these random lines to everything else they mentioned. Everything else they mentioned clearly had some motive behind it. Them telling us that F is the center of a circle, that's important, because we know that anytime you have a center of a circle, that has brought about two theorems already. A line from the center of a circle, if it bisects a chord in half, it meets it at an angle of 90 degrees. That's one thing. Secondly, we have an angle at the center of a circle. That's another thing, you see, meaning it's double this one, meaning it's double that one. So any information that is somewhat important, you can see it's spaced out from just this random information. So you want to really take note of that. Lastly, they have told us that B is equal to X. So we've spent a good 3-4 minutes just talking about the description, but it's all worth it, because these questions that we're going to have to answer, all of them, they are almost going to be, I don't know, it's just going to be pop and place. So the first thing for 4 marks or 2 is they say determine with reasons the size of each of the following in terms of X. So the first one is F1. Where is F1? F1 is down here. And from what we were talking about, it's so plain to see what F1 is going to be. And it's going to give us the 2 marks immediately. We have said that it is just double whatever this is. So we know this is 2x. We're going to say it's 2x, and we just have to give a reason. So we're going to say this is 2x. The reason is angle at the center of a circle is double the angle of the circumference. But in short, we can just write angle at the center of the circle. So here, F1, we're writing it out as equal to B. The reason there is just angle at the center of a circle. There you go. Angle at the center of a circle. Moving on to B. B, what does B have there? So there's A here, there's B here. B is angle C. They're asking us to get angle C. And we already, while doing the description, we already stated what C is. So this is to also highlight that in as much as your description sometimes seems like it's a waste of time, it's really not. It's the one where you're gonna save time, because all these 2 mark questions, you have to remember any mark allocation, you multiply it by 1.2. That's what tells you how long you should spend on those questions. So we did not spend two minutes on this. We're definitely not gonna spend 2 minutes on that, you see. All that time we spent it in the description, so we can like bank that time when we are at those questions. So C here, we can see that C is equal to, we can say it's equal to B, which is also then making it equal to X. The reason there is just going to be angles in the same segment. There you go. So with that being said, we can move on to the next questions. I don't want to make this too long because it's